Hello everyone, we're going to do a real quick kind of rundown of the main probability ideas you guys have talked about in this little mini unit we're talking about. So one thing that you might run into is the word mutually exclusive. And mutually exclusive essentially means, can these things happen at the same time? If they can happen at the same time, they are not mutually exclusive. Mutually exclusive events cannot happen at the same time. So if I pick a random student and they happen to be sitting in a math classroom, is it possible that that same student is also sitting in an English classroom? And the answer is no, these cannot happen at the same time. So that means these are mutually exclusive events. One can happen and the other cannot also happen at the same time. So they are mutually exclusive events. The second problem says, if I randomly select a student, is it possible that the student I select is a female? Of course, you could have a person who is a female who has a driver's license. So since they can happen at the same time, these events are not mutually exclusive. Okay? If they can happen at the same time, they are mutually exclusive. If they cannot happen at the same time, I said that backwards. If they can happen at the same time, they are not mutually exclusive. If they cannot happen at the same time, they are mutually exclusive events. Okay, conditional probability. This one says, what's the probability? Here's a table here. There's like an RH factor that you're either positive or negative for, and then you have some blood types. And it says, what's the probability that a randomly selected person who is negative for RH factor, so we're only looking at these people, we're only looking at the people that are negative, has type O blood. So the people that have type O blood, there are 28 of them out of a total of 65 people who are negative for type O blood. Now, when you do probability, sometimes you can reduce the fractions, and I'm going to use my calculator to kind of cheat it. If I do math frag, this one doesn't reduce. The other option would be to leave it as a percentage, so that'd be 43% or a decimal. So you could say 0.4307, or as a percentage, 43.07%. It depends how many decimals they tell you to keep when you round. What's the probability that a randomly selected person is A positive or B positive? So A positive or B positive. Those are the two different blood types there. There are a total of 139 people who are A positive and 37 people who are B positive out of the total population here is 409 people. So you add 139 out of 49 over 49 plus 37. There's nobody who's both, so you don't have any, you don't have to subtract any overlap. 139 plus 37 divided by 409. So we could write it as 176 over 409. 176 over 409, which as a decimal is, wow, really close percentage, 43.03%. I wonder how that worked out. Those are really close though. Okay, that's fine. But you're only looking at the people that are A or B positive, and you're going to add them together, and has a total of 409 people. So you get one of the people that has those type of blood out of the total population. Okay, these questions involve using the formula for adding two events. The probability here, you add the two events, but you have to subtract the overlap. You don't double count things. Now, I'm giving you these numbers, and you just got to realize that this is just straight formula work. If it's P of A is 1/4, I'm going to say, okay, first of all, let's work left to right. A or B, do I know probability of A or B? I do, it's 3/4. So we'll say 3/4 equal. Do I know the probability of A? Yes, 1/4. Plus, do I know the probability of B? No, that's my unknown, so I'll just call that X. Minus the overlap, A and B is 1/5. 1/5. Because we just did this, I'm going to actually do this without a calculator and get a common denominator for 4 and 5. So that would be 20. I'm going to make everything over 20. This would be 20x over 20, and this would be 4. Just because we just practiced 15 over 20 equals 5 over 20 plus 20x over 20 minus 4 over 20. And now I can just look at the numerator and solve this thing. So I'll say 15 equals 5 plus 20x minus 4. I'm going to go over here. 15 equals 5 minus 4 is 1. 14 equals 20x. Divide both sides by 20. 14 over 20 is 7/10. So 7 over 10 is the probability of B. Now, I'm going to do the same problem, but with the calculator. So just look at red. 3/4. You need to subtract 1/4. You need to add 1/5. And you get 7/10 that way. Okay. If you have a calculator, you don't need to do all this work, but we just practiced. We just took a test for that, so why not practice it? 7/10. Okay. Let's do the next one just with the calculator. Okay. It says P of A or B. I got that 2/3. P of A, I got that 1/3. Plus P of B, I got that 1/2. Minus P of A and B, the overlap, I don't know. I'll just call that my X. Okay, so I'm going to do 2/3. I'm going to subtract 1/3. That's 1/3. And then I'm going to subtract 1/2. And you get, what is that as a fraction? Math frac. Negative 1/6. Negative 1/6 equals negative X, so then X is 1/6. That means the overlap, the probability that they're both happening is 1/6. Okay. Don't let those psych you out. If you have a formula, you just kind of plug it in and just go through the numbers. And then you kind of sometimes have to go back and be like, what does all that mean? Well, there's not even any context to this problem. It's just using the formula. Last thing is replacement, and I just want to run down the cards. This is your sort of cheat sheet for all the cards. There are clubs, spades, hearts, and diamonds in a deck of cards, so that's 4 suits. If you divide the 52 cards by the 4 suits, there are 13 of each of them. Okay, and you can see them right there. It's ace to king, ace being low, it looks like the way they're counting here. So 1, 2, 10, and then jack, queen, king. Face cards are only the ones that have a face on them, so that's the jacks, queens, and kings. And there's a total of 12 of them. 4 jacks, 4 queens, 4 kings. Okay? If you know those things, you can usually do pretty well on a deck of cards. This says, what is the probability of drawing 2 face cards in a row without replacement? So, there are 12 face cards and there are 52 cards. That's the first event. And I'm going to say times, because these are independent events. If I do not put the face card I just pulled out back into the deck, now there are only 11 face cards left in the deck. And since I pulled 1 card out, there were 52. Now there are 51 cards in the deck. So when you multiply fractions, well, you can just, if it's a probability, I'm going to multiply across. 12 times 11 and 51 times 52. So 132 over 2652. 652. If you want to get that as a reduced fraction, maybe we can have the calculator do it. Math, frac, 11 over 221. Most of the time we have to reduce our fractions. Okay, one more. What's the probability of drawing an ace? There are 4 aces, 1 for each suit. So 4 out of 52. Replacing it, so there's still 52 cards in the deck again, and then drawing another ace. Well, there's still 4 aces because I put the one that I drew back in, and there's still 52 cards. So 4 times 4 is 16. What's 52 times 52? 2704. Now, as a fraction, 16 over 2704. Well, there's the decimal, really small percentage, but it's 1 over 169. 1 over 169. Okay. Or as a decimal, 0.59%. So really, really hard to do, okay? Less than 1%. All right, that's most of the ideas. If you can do those, you should be able to do pretty well on your checkpoints. So make sure you get those checkpoints done. Make sure you fill out all those notes. And make sure you smash that like and subscribe.